let's do an example. Here is a problem that you actually see in a lot of calculus textbooks. Let's take something like, what's the limit of sine 3x over x? And take that limit as x goes to 0. So how do you do this problem? That's what I want to show you. And we know that the limit of sine x over x tends towards 1 as x goes to 0. We've seen that graph, and we did an argument for showing how that's true. But here we've got sine 3x over x, which means that if x is, some number 1 over 100, 1 over 1,000, it's close to 0, and then what's the y value doing? Somehow the y value is 3 times as big, or what you're plugging in is like 3 times as big as the x. So this is, sine of 3x is somehow, if you think of the graph of sine of x, if you looked at sine of x over x, then here you'd have some x, and here you'd have the y value. But if you look at sine of 3x over x, then here's 3x. So you're taking this y value and dividing it by that x value. So what happens? If you want, pause the video for a second and take a guess. You think for yourself, like, how's this going to affect? If you want, you can graph this function in a computer algebra system like Desmos or Wolfram Alpha or whatever. Give you a second to investigate. Okay, if you thought about it and you have an answer, great. Or if you just want to enjoy the explanation, so here we go. What I want to do is one of these mathematical tricks. So there's an old saying that mathematicians, we really only do 2 things. That's multiply by 1 and add 0. Here I'm going to multiply by the number 1, observe. So 1 equals 3 over 3, no problem. So I can multiply this expression by the number 1 without changing its value. And so I'm going to multiply by 3 over 3. I'm going to get 3 times sine of 3x over 3x. And now I'm computing that same limit, but now this time it's easier to recognize. And so the next thing I'm going to do is I'm going to use that constant multiple rule to pull out this 3. That's one of the limit laws. And so what I've got now is I've got sine 3x over 3x. And at this point, you might look at this and you might suspect, like I do, that this limit's going to be equal to 1. And the reason for that, well, if I knew it was sine x over x, then that limits to 1. So 3x over 3x, it's really no difference because you're plugging in the same thing that you're dividing by. To explain that a little more fully, we can do what you call a change of variable. So you could say, let's let y equals 3x. And then just make the substitution into the limit. So this limit is 3 times, well, x is going to 0, so x is y over 3. So y over 3 is going to 0. And then you've got sine of y over y. Now, if I just had limit as y goes to 0, sine y over y, that's definitely equals to 1. That's just using a different letter, y instead of x for the variable. Now, does this y over 3 make a difference? No, it really doesn't, because if y over 3 is going to 0, then surely y is going to 0 as well. So actually, I can just get away with rewriting this. It's 3 times limit So y goes to 0. Sine y over y. And now this term, that's equal to 1. So I get 3 times 1 equals 3. So that's the answer. That's how to do that problem. And the idea is a change of variable, setting y equals 3x, and then doing this trick by multiplying by 3 over 3 to also get 3x on the denominator there. Then you can calculate the limit as usual.